right? Now let's move to the next topic, where we will try to understand each of these components and each of these factors which are basically being used to finally evaluate the total cost of the query, right? So our area of interest would be, what I'm going to do is I'm going to erase all of these things, and our area of interest in this case would be to evaluate this cost, right? Okay, let's try to understand how this cost is getting evaluated, this final cost. So when I run this query using explain, right? So if I simply rerun that explain current statement, as you see here, this gives me the visual explain analysis output, right? And we are seeing multiple things here. So first is what? Let's try to note down each of these points, right? So first is some random number. It's like 34.48, 140, 114.1, 148 and all those things. So random number, what are these random number? Second, uh, what are these, O, C, O, D, P and all those things. So these are basically aliases that I'll talk about very soon. Why, what is this nested loop? Then why for each of these it says unique key, for this it says non-unique key, again for this it says unique key, and for this it says full table scan, right? So what are these parts? We'll be seeing all of them as well. And then what is this final query cost, which is our area of interest to look at. So any query which we are analyzing, and if you're analyzing means either we want to know if any performance issue is there or not, meaning we are expecting a query to be faster, but due to some reason if it is taking time, then why it is taking time, and in order to evaluate that we have to analyze that. And how will we analyze that? One way is to make use of explain statement to understand which part your query is taking or getting evaluated as more cost. So to put into a one line, your query performance is basically getting evaluated as per your query execution cost. The more cost is, means there's some chances of improvement. The lesser cost means your query is performing well, and there's like less chance of areas of improvement. So somewhere I have read that if your query cost, right, if your query cost is like between like less than 1,000, means your query is performing well, and if your query is basically, if your query cost is between like less than 10,000, basically greater than 10, sorry, if your query cost is between like 10 sorry 1,000 and 10,000, then there's a slight chance of areas of improvement, chances of areas of improvement. And if your query cost, right, if your query cost is, let's say, like probably in millions or 1 lakh in numbers, right, then definitely there is a chance of areas of improvement, definite chance of areas of improvement. So in this case, right, definitely we have to look at why your query is uh, costing this much, right? Probably some random number would be there, but I have just mentioned greater than 1 lakh, right? So we have to definitely look at why 1,000 or not, right? I'll try to tweak the query in a way that our query cost will increase or fall, fall between any of these cases. So we'll see that as well. Okay, but the overall point is, if your query is falling between any of these cases, then definitely there is some chance of areas of improvement, and we have to look at why that is costing that much. As you see in this example, the query cost is 1579.12, which is basically greater than 1000 and less than 10,000. But it is close to 1000, right? It's like between 1000 to 2000. So yes, we can do some improvement here. But what is that improvement? So we'll see that very soon, right? So first point to make here is your query performance is getting evaluated based on the query costing. And if your query costing is falling between these cases, then take the decision according to that. Now, looking at this explain output, let's start from the full table scan. Okay. Now you may ask, hey Vikash, why if I look at this query, then I'm joining multiple tables. Why only full table scan happening on orders table? So basically, don't get confused with this O, C, O, D, and P. These are basically aliases of the tables that I have used it here. Okay. So O represents order, C represents customer, and all those things. Now, coming to the point here, it's like it says full table scan. You want to see the magic? See here. So if you look at the orders entity table, right, at the indexes which is being defined in this specific entity. So now if you see here, the primary index is basically applied on order number, and this is your referential index which is getting created on the customer number attribute on order table, right? I'll repeat. If you look at the structure of orders table, order number is a primary key and customer in number is the referential column which is reference to the customer number table, right? Look at this query. What we are trying to do is we are trying to fetch the order number and order date from orders table. And if you notice, as I said earlier, order number is the only primary key which is defined in this table, right? And what we are trying to do is we are trying to fetch the order date as well. Now I'm assuming that if you're at this stage, we are familiar with the indexing and all those things. Okay. So we all know that index has its own physical existence in the database world, right? Meaning when we create index, it goes to the index table space. So when we have created these indexes by defining the primary key and all those things, I know when you define the primary key, it automatically creates the index, but it goes to that specific index table space. But here we are trying to fetch the order date where we don't have any indexes or index created, and we are trying to fetch that column value from the orders table. So database will try to first look at the index table space if with this combination if we have any index created or not. If it doesn't find that, then it will perform the full table scan because that specific information is not present in the index table space, right? Hence it is trying to do the full table scan. Then you may ask, okay, if it is happening or if it is doing the full table scan, then why this number is very less as compared to others? Because if you look at the data on orders table, it has only like limited, I think 326 record. See, 326 record it has. Hence, to evaluate, even if it is doing full table scan, to do the full table scan, it just costs the 34.48. There is no specific unit to this number. Okay, the query cost is basically combination of many factors, and those factors are like disk read. So query cost factor is something like disk read, multiple block input output, CPU utilization, memory utilization, and all these things. So combining all these things, right, it evaluate the cost. So we cannot say that it is like 34.48 milliseconds. No. So it's just a number. Lesser the number is, better your query is. Your number is too high, then there's certainly a chance of improving your or optimizing your query. Now, since even though it is doing a full table scan on orders table, since it has like less number of records, and it has evaluated the cost as 34.48. So the first table which is being chosen by the database based on the cost, it internally does the evaluation, and as soon as it finds the lesser number of less number of this specific value, it will perform the first scan on that specific table. Okay, I'll summarize. In your query, if you have multiple tables, of course, in this case we are joining multiple tables, right? So forget about this query. Let's talk about, you are working on some complex query where you have many tables are used and lot of joins are happening. So out of that, your database will perform the scan on all those entities, and if it finds the lesser cost in terms of numbers, absolute numbers, and whatever the table will have the lesser number, the full table scan or full index scan will happen on that specific table. And in this case, order table has the lesser number, hence database had chosen this table to perform the full table scan. Or you can say that database had chosen this table to start the process, to start the evaluation process.